Hey everybody, welcome to InterviewBlog. In this video, we'll be covering the selection sort algorithm. So the question gives us an array of integers and it wants us to sort the array of integers using selection sort. The selection sort algorithm is a very simple algorithm, but it is not an efficient technique to sort a list of numbers. In selection sort, what I will do is I'll be visiting each and every element of the array, and for each element, I'll be traversing the remaining part of the array to find the smallest element and swap it with the current element. Let us now see this example. So in this example, first I'll be visiting this element 8 and the remaining part of the array would be this part. So in this part, I need to find the smallest element. So to do that, first I'll compare 8 with 2. Since 8 is greater than 2, my smallest element would now be 2. Now I'll compare 2, that is my smallest element, with 4. 4 is greater than 2, hence my smallest element will again be 2. Now I'll compare this 2 with 9. While comparing 2 and 9, we can see that 9 is greater than 2, hence my smallest element is still 2. So now I'll compare 5 with 2. While comparing 5 with 2, we can see that 5 is greater than 2 and hence my smallest element is still 2. Now I'll compare 1 with 2, but we can see that 1 is less than 2. So my smallest element would be 1 now. So what I will do is, in the remaining part of the array, I have found the smallest element as 1. So I'll be swapping this 8 with this 1. So my resultant array would be 1, 2, 4, 9, 5, and 8. So after the first iteration, we can see that the smallest number that is present in the given input array is present in the first index of the given input array. So now I'll pick this element 2 and I'll be checking the remaining part of this array. And now my current element is 2. I'll be checking if there is any element that is present in the remaining part of the array which is smaller than the current element. So my smallest element is now 2. I'll compare 2 with this 4 now. Since 4 is greater than 2, I'll compare the smallest element which is 2 with 9. Since 2 is less than 9, I'll compare 5 with the smallest element which is 2. Since 2 is less than 5, I'll compare 8 with the smallest element which is 2. But we can see that 2 is less than 8. So we do not swap any numbers here. Our smallest number, which is 2, is already present in the correct position in the given input array. So my array would now contain 1, 2, 4, 9, 5, and 8. This part of the array is now sorted. So my current element will now be 4. So initially, my current element would be the smallest element that is present in the remaining part of the given input array. So I will have 4 here. Now I'll compare 4 with the remaining part of this array. I'll compare my smallest element, that is 4, with 9. Since 4 is less than 9, my smallest element would be 4. Next, I'll compare 4 with 5. Since 4 is less than 5, our smallest element in the remaining part of the array would be 4. Now I'll compare 4 with 8. While comparing 4 with 8, we can see that 8 is greater than 4 and hence the smallest element in this case would be 4. Since the smallest element is already present in the correct position in the given input array, we don't have to swap anything. So our resultant array would be 1, 2, 4, 9, 5, and 8. So now this part of the given input array is sorted. Now my current element would be 9 and now I'll initialize my smallest element as 9. So in this remaining part of the array, we need to find the smallest element to swap it with the current element. Initially, our smallest element would be the current element, that is 9. I'll be comparing 9 with 5. Since 9 is greater than 5, our smallest element would now become 5. So now we'll be comparing 8 with 5. Since 8 is greater than 5, our smallest element would be 5. So we need to swap this 5 with 9. So our resultant array would now become 1, 2, 4, 5, 9, and 8. Now we can see that this part of the array is already sorted. So I'll pick my current element as 9 and I will initialize it as the smallest element. Now the remaining part of the array is 8. So I'll be comparing 9 with 8. Since 9 is greater than 8, my smallest element would now be 8. So we need to swap the elements 9 and 8. So the resultant array would now become 1, 2, 4, 5, 8, and 9. So after the swapping is done, we can find that the given input array is now sorted. So hope you understood the algorithm. Let us now analyze the complexity of our solution. So the best case, average case, and worst case time complexity of our selection sort algorithm tends to be big O of n square, and the space complexity of our algorithm in best case, worst case, and average case tends to be constant. So the space complexity of our selection sort algorithm tends to be constant because we are not using any extra space. We are just traversing the array, finding the smallest element, and we are swapping these elements. We are doing all these operations in place, and hence our space complexity tends to be constant. So why is the time complexity in all the three cases n square? For every element, we'll be traversing the remaining part of the array in search of an element which is smaller than the particular element. Even if the smaller element is not found, we need to traverse the remaining part of the input array. So our time complexity always tends to be big O of n square. So hope you understood the problem. Let us now implement it in code. So we got our selection sort function defined, which takes in an array. So I'm going to traverse the array. So I'll be saying for current index in range len of array -1. That is, I'll be traversing till the last before element, because when we reach the last before element, we will be performing swaps to arrange the element at the last before index. So after arranging the last before element, the last element will automatically be sorted. So I'll be traversing till the last before element. So what I'm going to say here is, first, I will assume that the smallest index is equal to our current index. So now I'll be saying for I in range, my element that is next to my current index. So I'll be saying current index +1, comma, till the last element of the array. I'll be searching for the smallest index. So for I in range, current index +1 to last element of the array. What I'm going to do here is, I'll be saying if the element is smaller than the element at my smallest index, then I'll be saying my smallest index as that particular index. So after finding the smallest index, I'll be swapping the elements which is in the current index and the smallest index, and I'll pass the array. So I'll write the swap function above. So I'll be saying swap function which takes in I, comma, j, which are the two indexes, and an array. So inside that, I will be saying array of I, comma, array of j is equal to array of j, comma, array of I. So after traversing the entire array, I will have to return the same array as our answer. So this will be our solution. So our solution has a time complexity of big O of n square in all the three cases, that is best, average, and worst case, and a space complexity of big O of 1, where n is the length of the given input array. So let us now test our solution. We'll be having our array with elements 8, 2, 4, 9, 5, and 1. So we'll be saying print selection sort of array. So let us now run our solution. So yes, we have got a sorted array with 1, 2, 4, 5, 8, and 9. So let us now see another test case. You will just have 3, 2, and 1. So we got 1, 2, and 3 as our output. So our solution works fine. Hope you understood the problem. Do subscribe and check out our channel for more videos. Thank you so much.